Coming up next, a special technology and innovation edition of Arizona Horizon. We'll hear about an Arizona company contracted by the Department of Energy to produce radiation-hardened computer chips to be used in particle accelerators. We'll learn how the city of Mesa is looking to promote technology with a heavy concentration of educational institutions along Power Road. And Arizona has a shortage of engineers. We'll see what's being done to address that problem. Those stories next on Arizona Horizon.
Arizona Horizon is made possible by contributions from the Friends of Eight, members of your Arizona PBS station. Thank you.
Good evening and welcome to the special technology and innovation edition of Arizona Horizon. I'm Ted Simons. We begin with a look at Ridgetop, a Marana-based company that's working with the U.S. Department of Energy to produce radiation-hardened computer chips to be used in particle accelerators. Ridgetop's founder and CEO is Doug Goodman. It's good to have you here. Thanks for joining us.
Well, thanks very much.
A couple of $1 million contracts from the Department of Energy.
Right.
For what?
What we do is, the problem is to convert analog sensor data to digital form so it can be processed and the artifacts that Dr. Krause was talking about can be extracted. Where we fit is in the middle. We convert analog to digital, and we have to do it in a way that is radiation hardened, which means that incident radiation will tend to degrade electronics, semiconductors in general. And what we have to do is apply mitigation measures to make sure that the chip we make doesn't degrade. And it retains its measurement accuracy, its dynamic range, its linearity. All these arcane kinds of specifications are preserved in the presence of radiation.
And this is the kind of thing that you wouldn't necessarily need for run-of-the-mill, everyday computer chip operations. But when you're talking about a particle accelerator or medical devices, other things, you need this kind of protection, correct?
That's correct. Space electronics, anything that, like one of the issues in space is that once you get outside the Earth's atmosphere, the magnetosphere protects us. It takes those particles. It shields the terrestrial component. What we have is a way of hardening these chips when they're used in critical environments. If you have a cell phone or a tablet or something like that, it's not as critical as it is in a system that is used for magnetic resonance imaging or have a system on the Large Hadron Collider or in space electronics. It really requires additional attention. But the interesting thing is that as process geometries have gotten smaller and smaller, it's also opened up the opportunity to make things faster and faster in conversion speed. And to get the degree of fidelity that they need, these scientists like Dr. Krause need to really look at these arcane collisions that occur, requires that we get the measurement very, very close to where the collisions occur, which increases radiation, and also preserve the speed, the linearity, all those kinds of specs that come into it.
So basically data to digital at a faster speed and protecting not only the information but the chips themselves.
That's correct, and it stems from the chips themselves are populate circuit boards, and the circuit boards go in racks. And if you look at the Large Hadron Collider or any of these, they're immense in size, and they have to be very, very accurate in how they make these measurements. A lot of these types of collisions are rare. They're hard to capture. They need extremely sensitive electronics, and that's what Ridgetop provides. We actually got started by looking at the physics of failure of these devices when we started the company 12 years ago. And we collaborate closely with Arizona State University, with researchers over there. It's wonderful to work with ASU and the people there and kick around ideas and find ways to make electronics more robust.
And that relationship is developing, correct? You're heading out toward Polytechnic, to the...
Yeah, at this time, I'm very impressed with what ASU has done over the years in growing the microelectronics component of, which is the world we live in at Ridgetop. Mm-hmm. But the group that we're dealing with primarily is in Tempe. And there's a lot of expansion plans out in East County. We're opening a design center in Mesa for Ridgetop. We're actively hiring engineers, what's called mixed signal engineers, which are analog to digital or digital to analog. And we have a lot of growth plans for East County.
Interesting, we were talking about, before we got into the contracts and the whole idea of data to digital and making them faster and radiation hardened, there was, and I guess there still is, a kind of a canary in the coal mine aspect to what your company does. Are you basically stamping shelf life onto certain computer chips and certain sensitive electronic information?
Well, in the case of the prognostic, we call it prognostic canaries, and a lot of these degradation effects scale by either applied voltage or area, so it allows us to create test structures on the chip. And it will provide exactly what you're talking about. It will give you early warning of an impending failure. Now, this is really important if you're in an avionics or aircraft situation where you want to switch over to a backup system quickly and seamlessly. Or more recently, what's happened in prognostics is a lot of the stuff you hear about on Wall Street with these millisecond level trades and at the speed of trading securities. There was a meltdown on the Tokyo Stock Exchange recently. All these kinds of things where electronics are getting pushed into areas that they didn't exist before. They're being taxed, they're being pushed there's high power dissipation, there's heat, there's performance parameters. All these things can drift and change with time. What Ridgetop has done is we've worked very hard with our research staff to categorize the types of failures and types of degradation metrics and create specialized structures that provide just what you said, canaries.
And these are literally built-in signals.
That's correct.
In these instruments.
That's right. And you can apply prognostics in a general sense. We have a 5-level model where you start with the die level, like we're doing with the collider, particle accelerator. There's a package level, there's board level, there's module level, all the way up to system level. And there's signatures that you can extract that indicate the degradation that's going to happen on the system, whatever you've targeted, each one of those 5 levels. As a company, we started at the die level. That's where people were saying, well, these semiconductors don't have a 60-year life anymore. It's down to less than 10 years, and it's less than 8. And it's getting to the point where there's some irreversible damage that occurs. Now, people with cell phones shouldn't worry because there's a refresh every year or two on those. But in critical systems, it's absolutely critical that when people are putting electronic control systems in harsh environments, that they're aware of these things. And Ridgetop provides that.
It almost sounds like the reverse of Moore's law. I mean, these chips are becoming less and less lengthy in duration.
Yeah. So there's a corresponding thing a lot of people don't talk about. People do talk about Moore's law getting, more and more, getting smaller and smaller. Channel lengths down to 20 nanometers, let's say, down in the nano range. But what happens then is there's a corresponding increase in the kinds of damaging effects that can crop up. And system designers that are going to use these chips really have to understand what they're doing in that area, what the vulnerabilities are. So we've also created at Ridgetop some instruments that allow people to do some of that testing themselves. And so we're working with a lot of people in the commercial sector that are saying, okay, well, it answers the question, how long will this chip live? That's really what it comes down to.
Well, it's interesting stuff. Congratulations on your success down there, and good luck in future endeavors here. It's good to have you on. Thanks for joining us. We appreciate it.
Thank you very much.
We continue our technology and innovation special with a look at Mesa's efforts to transform the city's Power Road corridor into a knowledge-based economic engine. I talked about the Power Knowledge Corridor with Mesa Vice Mayor Scott Summers. It's good to have you here. Thanks for joining.
It's good to be here, my first time.
Well, good for you. We'll have you back sometime, as long as you just tell us what is the Power Knowledge Corridor.
Well, first of all, Mayor Smith would be upset if I let you say this is just Mesa's effort, because this truly is a regional effort. It involves the Phoenix Mesa Gateway Airport and its board. Gilbert is involved, the county, Queen Creek, even Pinal County. We're all very excited about this. The Power Knowledge Corridor runs along Power Road and has a unique set of assets that we feel position it to become a cornerstone for science and technology research in Arizona, the benefits of which will be shared throughout the state.
What are those assets?
Well, you have a cluster of universities and educational assets. It is the foundation of which is ASU Polytechnic and the Tier 1 research that they're doing. But also you have Chandler Gilbert Community College and aerospace and nursing programs there. East Valley Institute of Technology is providing workforce development in the region. At the north side, you have MCC Red Mountain campus, and we also have a medical school. A.T. Still is just off of Power Road.
So, chicken and egg question here. Were those things there first, or did the idea of getting some sort of cluster, some sort of corridor, get those things there?
A lot of those things were already there, and the question was, how do we take all these assets, pull them together, create a brand so people understand what the opportunities are for this region? It is not too dissimilar from what North Carolina did many years ago with the Research Triangle. They have university assets. It is home to hundreds of high-tech companies and enterprises, and that's what we're trying to accomplish here.
But last question on the location here, though. Why along Power Road? Was it the airport, proximity to the airport mostly? Why Power Road and not another road out there? What do we know?
Power Road, of course, is a key arterial street, though. But really, that just happens to be where a lot of those assets are. MCC, Boeing, A.T. Still, the universities. But also it focuses a lot on the assets that are the airport. We have 3 10,000-foot runways, and we have a foreign trade zone on top of a military reuse zone that provides a financial edge to companies who want to compete globally. Also, AZ Labs is now located there. We have room for 200 researchers doing secret work or very sensitive work. It is the only secret research institute in Arizona, one of very few in the United States.
And again, focusing on high tech, on healthcare, bioscience, aerospace, the whole 9 yards.
Engineering, science, technology, math, STEM, absolutely.
Yeah. Collaboration, getting the cities to cooperate, getting the entities to cooperate, getting everyone to play along. Challenges?
Challenges is we just want to make sure that we keep moving forward. We have had just an absolutely phenomenal era here over the last 4 years, particularly of regional cooperation, collaboration. We've seen Pinal County, Queen Creek, Gilbert, Mesa, all finally working together to brand this area, build it, because once again, the benefits aren't just going to be Mesa. Gilbert, Queen Creek are also along Power Road.
You mentioned the word branding, and I was going to ask you about that. The importance of creating a brand out there. You got the name, the Power Knowledge Corridor, that's a start. But getting folks to think of that area as a place for multi-generational, high-tech kind of learning. How do you do that?
Well, it's multi-step process, and certainly all of our partners are going to be involved with it. We need to have the universities continue to reach out and utilize that brand to show how they're able to take that brand and the ideas that they're creating, like, for example, the green biofuel, and turning that into enterprises. And that really is what's going to establish the brand, showing successes in taking that brand, utilizing our assets, and turning them into companies and high-wage jobs.
I saw a video of Mesa, the mayor, Scott Smith, mentioning the Harvard Business Review, and a quote from the Business Review: competitive advantage lies increasingly in local things. That's the emphasis out there, isn't it?
It absolutely is. This is really a local effort. Certainly the state and our federal partners need to be involved with this, but really the strength in this particular project is really it's a ground-up project. Coming from the universities, from the businesses in the area, with support from the city, and coming together for a collaborative effort.
How difficult has it been, though, to get that collaborative effort and to get things off the ground and moving up and operational, if you will, in very tough economic times, past few years especially?
Well, in some ways, I think that tough economic time drives people together because you're looking for ways to leverage the assets that you do have. So I think we were very successful in taking what has been a depressed economy, taking advantage of that, bringing those partners together, and a rising tide lifts all boats, right?
So if someone's watching right now and they say, let's say they have a kid that they want maybe to go to a university and study the biosciences or high tech or something, maybe they're interested. They're in midlife, something along those lines, and they're looking for some more educational opportunities along these things. Where do they go? What do? They just drive out there and start one-stop shopping? How does it work?
they will have many opportunities. Maybe they are going to start out at Chandler or Mesa Community College or any one of the community colleges. Perhaps you go to Arizona State University. If you're into technology and you get into a company, you have the opportunity to go use AZ Labs perhaps. We're also looking to start a business accelerator next to the labs, looking for new high-tech businesses to incubate them, to help them grow and create jobs. So the way to get into this is there are many doors.
What about the doors for the near future? What kind of focus are you looking at here?
Right now it's infrastructure with State Route 24. We're just starting the first leg of the State Route 24 because connectivity is extremely important. Power Road, we have some new assets going there. Another phase will be the business accelerator, but also continued infrastructure development on Phoenix Mesa Gateway Airport.
Last question. Vice Mayor of Mesa, I've asked Scott Smith and Mayor Smith this as well. It seems like there's a concerted effort to change Mesa's image. Is that what am I reading this correctly here? It seems like Mesa has decided they're going to start taking some steps that maybe in the past they wouldn't have.
I think our image has been much improved, but all we've done is taking our assets that we've always had and we're moving them to the forefront and said, this is what Mesa has to offer the region. And I mean, people like that message.
All right, very good. Good to have you here. Thank you for joining us.
Great to be here. Thank you.
We conclude our technology and innovation special with a focus on the people who make innovations happen, engineers. The dean of ASU's engineering school says that state employers are having a hard time finding qualified engineers. So the school is working on ways to recruit and educate students and help keep those graduates in Arizona. Paul Johnson, dean of ASU's Ira A. Fulton Schools of Engineering, talked about efforts to address the engineering shortage. It's good to have you here. Thanks for joining us.
Thanks for inviting me.
A little surprising, maybe, about a shortage of engineers. What kind of shortage? What are we talking about here?
Well, there's a shortage, and it's going to get worse. So it's been mediated a little bit by the economy, but for a little while we've had sort of the demand and supply being okay. What we have in front of us is about 40% of the engineering workforce is retirement eligible. Many of those people have sort of held on to their jobs for during the weak economy because they're worried about their retirement accounts, and we're starting in a phase where they're going to start retiring and the economy is starting to pick up. In fact, we're seeing that in all the indicators of the recruitment with our students. For example, we have a career fair that we're holding in a couple weeks. We have our own career center, and so we get postings, and we keep track of the number of postings. We keep track of the number of companies that are interested in the career fair, and the number of postings is up 50% this year. The number of companies coming to the career fair has actually steadily increased during the weak economy, and now it's really taking off again. So that's the situation.
Is there a certain type of engineer we're talking about? Is it across the board? Is it relatively focused? What kind of engineers are we seeing a shortage of?
Yeah. So there's a pretty broad spectrum of engineers and engineering skill sets and things like that. I think at the current time, if you talk to employers, what they'll say is there's a shortage of people in sort of maybe the 2 to 5 year time frame of experience. That's some people with some early experience. They're looking for a lot of those, and they're having trouble finding that group of potential employees. They're also in certain areas in engineering. There's more demand than others. For example, the 3 primary areas right now are sort of computer science, computer systems. A lot of it is spurred by our iPhones, all the apps, the smart devices and the iPads and things like that. Electrical engineering is another one of the areas, and mechanical engineering is another area.
So you mentioned the brain drain, folks that had worked on these kinds of things, developed these kinds of things for that matter, getting older, moving on. Are there simply not enough young people to come around, or are there enough young people but they just don't seem to be qualified, they're not there yet? What's the dynamic?
I think we're in a situation where if you look at the numbers, so there's about, depending on whose numbers you use, there's about 1.5 million engineers across the country. 40% of those retirement eligible. Probably in the next 5 years, most of those will retire, if not within 10. The number of engineers produced each year is, when we hit that phase where those people are retiring, the number of engineers produced is not going to match the rate at which they're retiring. In addition to that, you've got these new fields that are developing and new companies starting up all the time, and they need. It's not just a replacement of the people that are retiring, but it's every time an engineer invents something new, and an industry sprouts up because of that, it's like you need a whole new flavor of engineers to help feed it.
Well, I was going to ask that. I know you got your Intels, your Boeings, your Raytheons, your Honeywells, and I'm imagining they're looking for folks. Is that the greater demand there, or is the greater demand with these smaller startup companies?
It's in both places. So the larger companies are the ones that are really worried about the brain drain as a result of retirement. The newer companies, they're the ones that are, the new companies are always sort of at the starting edge of technology, and that's why they're new companies sort of starting up. And so they're trying to take new ideas, bring them to the marketplace. There might be devices or solutions or processes or software. And so they need students that are graduating that are prepared in those. And so, usually in a university system, the curriculum will sort of lag a little bit in terms of, where technology is going. So it's really important to try to get your program such that the students are matched up really well with these small startup companies, so they can just go right into them and be working for them.
How much of an impact, and we hear this, that a lot of kids get their engineering degrees at ASU, here in Arizona in general, and then leave because there are more attractive jobs elsewhere. Now we're hearing that folks that are here can't find enough engineers. Are the jobs just not attractive enough? Are there not enough kids graduating? Well, give us that equation.
So if you look at the data, it's kind of interesting. Actually, Arizona employers, there's a good message in it for Arizona employers who hire students particularly from ASU. So what sometimes people call the sticking rate of students is about, at least with our undergraduate students, more than 70% of them are still working as engineers in the state after 5 to 10 years of graduating from ASU. There's a strong regional preference of our students when they graduate to actually work in this area. So that's a really good thing. So if the local employers come hire our students, there's a really good chance those students are going to stay. They're at the advanced degree level. This is where there's more of the issue because the advanced degree level students, the PhDs and the master's degrees, will look a little bit more regionally because they tend to come from all over the place. The difference is at the undergraduate level, 70% of our students are from Arizona, 20% are from across the country, about 10% are international. At the graduate level, the students come from much farther away and many more places. So you only get about 30 to 40% of those to stay in the state, and that's where they're going to go where the attractive jobs are.
So at the school, what kind of plans do you have to recruit more students, to retain them, and to keep them in Arizona? I mean, is there something you can do? Are there actually focused plans?
There really are, and this is actually one of the fun things about being the dean of an engineering school, is to get to work on things, because it's a topic, particularly attracting young students to come to college in engineering is a topic that resonates with sort of anybody who's ever been an engineer and people in science fields and things. So they really want to help in this. But the key thing, so our strategy right now has been what we want to do is we want to make young potential college students very aware of what engineering is all about. Because there's sort of stereotypes out there. You have to be good at math or whatever it is. And so the first thing we do is we try to communicate to them what it is that engineers really do. So if you want to, what I always tell them is, if you want to create things that don't exist, if you want to work on things if you want to work on things that really matter, if you want to be the problem solvers, if you want to be the innovators, if you want to start companies, look at engineering, because here's examples of all those things you can do that. So we try to make that there, and then we have our students at ASU actually go out and work in the classrooms with teachers in the K-12 system. So they can see the students in high school and below can see what a college student looks like in engineering, can see that they're actually enjoying what they're doing, they're having fun, they can tell them about all the exciting things that we're doing. We also go all the way down to 5th grade. We host the first Lego League competition in the state. We've got programs all the way through high school. We have summer programs. And then when the students come to us, we have to make sure we keep them.
Yes.
So students go through first robotics these days. They go through the first Lego League. They're all, they know competitions. They know, technology can be exciting. Creating things can be a lot of fun. So we've actually had to, in the last 4 or 5 years, totally rework our program at the university so that in the old days, and actually most engineering programs are still like this, you come into the university and you sort of have to make your way through physics and calculus. And if you do that, then they sort of talk to you when you're a junior. But the generation these days, if you don't excite them, with what you're doing, if they don't see engineering early on, they're going to go somewhere else in the university. And so we've changed our program. So we have this engineering from day one philosophy. We bring the students in, they're solving problems, they're creating things, they're doing real engineering stuff just as freshmen in the first week.
Well, it'll be interesting to see how well that develops and how well we can kind of minimize that particular shortage. It's good to have your good information. Thank you so much for joining us. We appreciate it. And that is it for now. I'm Ted Simons. Thank you so much for joining us on this special edition of Arizona Horizon. You have a great evening.
If you have comments about Arizona Horizon, please contact us at one of the addresses on your screen. Your comments may be used on a future edition of Arizona Horizon. Thank you. Arizona Horizon is made possible by contributions from the Friends of 8, members of your Arizona PBS station. Thank you.
Support for Arizona technology and innovation on Horizon comes from Avnet, Arizona's largest public company, one of the largest distributors of electronic components, computer products, and technology, celebrating 50 years on the New York Stock Exchange. For information, avnet.com. And from Intel, helping to transform the lives of millions through education, working with countries, communities, and schools worldwide to bring the resources and solutions needed for advancing education. For information, intel.com.